A very warm evening again. So today we're going to be discussing analytical geometry, right? This will be suitable for grade 10 to 12, but because concepts in analytical geometry they are from grade 10, 11 and then 12. So the only part for 12 that is circle analytical geometry, but the rest suitable for everyone. Okay, so we can start by looking at the first question, right? Analytical geometry is usually a section we must always get 100%. So we're just going to go through over what are some of these concepts, right? This is the first problem we're going to look at, and it says that in this diagram ABCD is a quadrilateral having vertices A, B, C and then D. Then we are informed that M is the midpoint of BD. So we got BD here, M is the midpoint. That means the distance here should be equal to the distance there. Okay, so that means BM is equal to MD, right? So for 3.1 it wants us to calculate the gradient of AC, which we can easily get because we have the points, right? Let's remember the gradient formula. So the gradient of AC will be y of C minus y of A, x of C minus x of A, of which y of C, the y value is negative. I'm gonna write straight here because of space, but you know that you can, you write it properly. So the y value of C is -4, and then the y value of A is 1, and then the x value of C is -3, the x value of A is 7. So because of that you will get -5 over -10. I think it should be half, and it's a positive gradient because you can see that line kind of looks like this. It's having a positive gradient, right? 3.2.1 then says determine the equation of AC in that form. So to get the equation of AC, let's look at AC. This is A here, and then this is C. Now we drew a dotted line just to indicate that is our AC. Now we want its equation. We know that the equation of AC, it's a straight line, so the general equation of a straight line is what? Y equals to mx plus c. That means we need to get the gradient because we are focusing on what? On AC. We need to get the gradient of AC so that we know what is M. So we already calculated the gradient of AC on the first question, so we can simply say y is equal to half, because M is what? M is half, and then x plus c. Now how do we get c? Remember, to get c you can either substitute A into the equation or you can substitute C. So I'm gonna choose A. Since A is 7 and 1, that tells me that my x value is 7, my y value is 1. So in that case I'm going to say y is equal to half x plus c, which means that 1 is going to be equal to half. What is our x? Our x is 7, and then plus c. Then we can say 1 minus 7 over 2 will give us c. That means c should be equal to what? 2 over 2 minus that is minus 5 over 2. So that means that therefore the equation of AC is y is equals to half x minus 5 over 2. 5 over 2 is around -2,5, which makes sense because around here it is -2,5, but you know that x is 0. Okay, so because it's the y-intercept, right? Remember that is the y-intercept. Please do check for me if the values are correct, because usually I'm gonna be using my head to calculate there. 3.2.2 it says determine whether M lies on AC. You see this M, even though when I made my little construction there, it looks like M is on AC, but we need to prove it. How do we prove that M lies on AC? Whenever you need to prove that something lies on a line, you use collinear points, right? So you use how did they use it? How did they say it? There's a nice word for it. I saw it on one of the IEB papers. They said test for, oh yes, so it's a test for collinearity. It's a test for, you test for collinearity. The moment they say determine whether something lies on a certain line. Okay, so how do you do it? It's simple, guys. You calculate the gradient of MC, then you calculate the gradient of MA, then you calculate the gradient of AC. Luckily for AC we already have. For AC it's half, right? Meaning you calculate the gradient for the whole line. Then you calculate the gradient between here and there. You calculate the gradient between there and there. If you can get that gradient, if all of those gradients are the same, that means M must be lying on AC. But do we have the coordinates of M? We don't have yet. But we were told that M is a midpoint. That reminds us of the what? Of the midpoint formula. So we can use the midpoint formula to get the coordinates of M. So to get the coordinates of M, we can say x1 plus x2, of which I like to say, since M is the midpoint of BD, I can say x of B plus x of D over 2, and then y of B plus y of D over 2. Now, x of B is what? Is negative 2, and then x of D is 8, right? Y of B is what? Is 9, and then y of D is negative 11, and then you divide by 2. Then what is the answer that you get? I think this will be 6 over 2, which is 3, and then I think this should be negative 2 over 2, which is negative 1, if I'm not mistaken. Sorry, yeah, 9 minus 11 should be negative 2, yeah. So that means that M is equal to that. So we can write those coordinates here to say M is 3 is to negative 1. Then we can get the gradient. So we calculate the gradient of, we can start with MC or CM. The gradient of CM will be y of M minus y of C over x of M minus x of C, which we can get by saying what? Y of M is negative 1, right? That is negative 1. Y of C is negative 4. And then x of M is 3, and then x of C will be negative 3. Then how much would we get there? So we get that the answer is half. Then you can calculate the gradient of MA or AM. The gradient of AM is going to be y of A, right? So it cannot be 1 minus negative 4, and then 7 minus negative 3. I think the answer should also be half. So therefore, since the gradient of AC is equal to the gradient of AM, which is equal to the gradient of CM, that means M lies on, AC. Alright, so I hope that is clear there. I hope that is clear. So it's just about calculating the gradient of the portions and then of the whole length of the whole line. So that is 3.2.2. Okay, that is how we test for collinearity, right? To check whether the points are collinear. C, A, and M, they are collinear. They lie on the same straight line. Okay, so now we can try to do the next one. So some of these things we might probably need them but it's fine. Let's just remove them here and then continue. Now for 3.3, right, it says that prove that BD is perpendicular to AC. Now BD is this one. Prove that it's perpendicular to AC. That is nice because we already calculated the gradient of BD. Did we? Oh, we didn't. So the gradient of BD is going to be y of D minus y of B all over x of D minus x of B, which means we can say negative 11 minus y of B, which is 9, and then we can say 8 minus negative 2, right? So that means you have negative 11 minus that is, I think, is negative 20 over 10, right? So the answer is negative 2. Then we know that the gradient of AC is equal to what? Is equal to half. Now we then say the gradient of BD, when you multiply it by the gradient of AC, you get negative 2 multiplied by a half. That the answer is negative 1. The fact that you got an answer of negative 1, you say therefore BD will be perpendicular to AC. If the product of the gradients is negative 1, it means those lines are perpendicular. So we have a 90 degrees there. Okay? These are things we did in grade 10, grade 11, so I'm hoping that we are still together. 3.4.1 then says calculate theta, the angle of inclination of BD. Now we enter grade 11. This is BD here, right? We need theta, the angle of inclination. We know that for the angle of inclination, tan of that angle of inclination, tan theta is going to be equal to the gradient of what? Of BD. Of BD. We already know that the gradient of BD is equal to what? The gradient of BD, we got it to be equal to negative 2. So we put it here. Then we say reference angle will be equal to tan inverse. Remember, you put a positive 2, not a negative 2. So what is tan inverse of 2? Thank you so much. So that will be 63,434,94882 degrees. Remember, don't round it off, right? Then you then say therefore theta will be 180 degrees minus that reference angle. Okay, so that means theta will be 180 minus that, minus the 63,4 what until 2 degrees. So that means theta will be equal to 116, right? 116,57 degrees, right? Right, that is going to be theta there. Why are we getting it like this? Because once you get negative, it means your line is slanted like this. Remember, you know Nike, right? Nike is like this. Should remind us of a positive gradient. So a negative gradient will be looking like this. That is why here for BD we are getting a negative gradient, because it's like this. So the angle of inclination is always measured from the x-axis anti-clockwise to where your line is. So now it means you're gonna have to say, because it's an angle greater than 90, you're gonna say 180 minus the reference angle. Then you get it. If I wanted the angle of inclination for AC, it would be this angle here, this small angle here, and I wouldn't have to say 180 minus 90 minus reference angle, because that line has a positive gradient. So I want to say to you, whenever you write tan of angle of inclination is equal to gradient, if the gradient is negative, you are always going to say 180 minus the reference angle. But if the gradient is positive, you just simply say theta is equal to that angle, the tan inverse of that positive number. Okay, right, so that is what we have. Hope we're still together. If you do have any question, Please don't hesitate to ask. Then we move to the next one. 3.4.2. It says determine the size of CBD. CBD. So you're now looking, you now know it's usually very beneficial to label. You know that here it's 116.57 degrees. Now we are looking for this one, right? How do we get that angle there? Very, very nice question. How do we get that angle there? Any idea? Okay, it's a good thing to say you can find, right? You're more than welcome to say I will find the length of, I'll find the length of MC, right? Then get the length of BM, then get the length of BC, then use cosine rule to get this angle. It's very much okay. But you can also maybe do this, right? Tan beta, right? Or you can use any other. You can say maybe tan. I like phi. Tan phi is equal to the gradient of BC. Tan phi is which one? Phi is the angle of inclination here. Understand me? If I can get the angle of inclination of BC, that means I'll have phi. Then from there I can simply say this minus that phi will give me this angle using the exterior angle of this triangle here. Isn't it? Right. So you must always check, right? You must always check that. Can you not do something, especially when they've already asked you to calculate a certain angle of inclination? So tan phi will be equal to, I think, we didn't calculate the gradient of BC. The gradient of BC will be 9 minus negative 4 over negative 2 minus negative 3. That means tan phi would be equal to 9 plus 4 is 13. 13 over this is 3, right? Yeah. So negative 2 plus 3 is 1. Is it 1?
Sir?
AM.
Sir, before we continue, for 3.4.1, you say when the reference angle is, when the gradient is negative, and then the reference angle is also negative, what do we do?
No, I said when the reference angle, no, when the gradient is negative, your reference angle is bigger than 90. So we have to say 180 minus, no, we have to say 180 minus the reference angle.
When do we add 180 to the reference angle?
When do we add?
Yes, sir. Or we never add?
We never add.
Okay, sir.
Yeah.
Okay, so now I understand.
Alright, so here we'll say, since this is a positive number, right, because the gradient is positive, BC is like Nike, isn't it? So we can simply say tan inverse of 13, then that will give us 5. So I think tan inverse of 13, it's a very steep gradient, you can see. It gives us 85.60. 60.129.465 degrees. So that means CBD, right? CBD will be equal to 116.57 degrees minus that 85.6 until 5 degrees. Say exterior angle of a what? Of a triangle. So therefore CBD will be equivalent or equal to 30.97 degrees. Right, so that is the angle here. Quite interesting question, right? So that that should be the angle there. We can do this, so it will be 30.97 degrees, and then we also know phi. Okay, so then they say determine the length of AC. I think here we can remove on top here, or maybe let me do this. Copy. Yeah, we need the length of AC. Now there is AC here. Ow, that one is a very simple question, right? AC, just a sec. So to get the AC, right, because AC is this whole length, right? So that one we can use the distance formula, right? So for 3.4.3 we can say AC will be, AC squared will be equal to x of c minus x of a squared plus y of c minus y of a squared. So the x coordinate at c is -3, and then the x coordinate at a is 7. The y coordinate at c is what? Is -4, and then the one at a is 1. You put that in your calculator, then you're gonna root both sides to get the length of AC being equal to what? 100 plus 5, plus what? 25, 125. So it gives you what? Is it the root of 125? Yeah, so we should give you 5 root 5. Then you'll be good. 3.4.4. Determine the area of ABCD for 5 marks. ABCD. So this is A, B, C, D. So it's for the whole quadrilateral. We need the area, right? I think if we can remember, I think there's like a 90 degrees here, 90 degrees, 90 degrees, 90 degrees. So we're not looking for the area there, right? We got the length of AC, right? With the length of AC, and then since here it's a 90 degrees, so we can simply say AC is the base. Now we just need the height. So to get the height, we can just get the length of MD. If I can show you on a clean one, remember that here it's a 90 degrees, a 90 degrees, a 90 degrees, and a 90 degrees. So that means this whole triangle here is a 90 degree. It's a right angled, no, it's 2 right angled triangles. So this would be your base, and then here could be the what? It's gonna be the height. You do this thing for this one, and then you do a similar thing for this. This is the height. They share the same base. So in that way, I should just get the length of MD, and then for my height, and then the length of MB for the height. Okay, which should be very simple to get. So we can say for 3.4.4, the length of MD is going to be the root of x of D minus x of M all squared plus y of D minus y of M all squared. Remember, there is no mark for the formula, right, in grade 12, but there is a mark for the formula in grade 10, right? So, but this is just to guide you. So x of D is 8, and then here we have 3. Oh, what was the y of M? Was it -1? I think it was -1. Then we can get MD. Right, so that means if you punch that in your calculator, right, you should get -11 plus 1 squared we should get 5 root 5. Even so AC is equal to MD. That's quite interesting. I'm getting 5 root 5. If you are getting a different thing, please tell me. So also I'm going to get the length of MB to save time. So MB is going to be the root of x of B is negative 2, and then x of M is 3, and then y of B is 9, y of M is we said, I think, negative 1. So we get MB is being equal to what? So that would be negative 5 squared plus 10 squared. 5 root 5. So therefore the area is simply going to be for the first triangle, which is you can say triangle, area of triangle ADC plus the area of triangle what? ABC, which is going to be half the base, which is AC. AC we found it to be 5 root 5, and then half base times height. The height is also 5 root 5. Then you say plus half 5 root 5 into 5 root 5. Then you get the area as what? 5 root 5, right? Squared. So you get 125 units squared. So that will be 125 units squared. I hope that has reminded you for grade 11, grade 10, in terms of the analytical geometry. Remember, it's usually question 3. So there we must make sure that we come out of the exam with that 23. This is why it's so easy to pass paper 2. Imagine you have this 23, you got your 40 in Euclid, you're already on 63. We add 10 or 15 from stats, you're already on around 75. Is it 75? Yeah, around 75. You add a bit of trig, you're already on 90s. Understand me? So it's very, very easy to pass paper 2, guys. Please practice it. Then we're going to come to grade 12 one, which is this part. It's usually question 4. Then question 5 is your trigonometry. By now you should have the structure in your head, ne? Because usually the structure does not change. So in this diagram you got a circle having a center at the origin. Let's not underrate that statement. The fact that it's at the origin, we are given a coordinate. At O there it's 0 and 0. Okay, and then it's passing through this point. PO is a what? Oh, by the way, this means that this is equal to that, is also equal to that. But inside here we know that this is equal to this, right? The diameter RS of the larger circle is a tangent to the smaller circle. Wow, it's a tangent to the smaller circle at O. If you have a tangent, if this is a tangent and then you have a radius, already you should be reminded of Euclid that you have third perpendicular to radius, isn't it? You should already indicate that. Let me do this. Yeah, we're saying this, but I wanted to indicate that OM is equal to MP. Right. Calculate the coordinates of M.
I'm sorry, what is OM equal to MP?
Yeah, OM is equal to MP. Radi. Let's not forget our Euclid. Yes. Radi. So they want the coordinates of M, right? It means M is the midpoint, right? So if it's the midpoint, you should be reminded of the midpoint formula. So we can say M will be equal to the x coordinates of O plus the x coordinate of P over 2 the y coordinate of O plus the y coordinate of P over 2. The x coordinate of O is what? Is 0, and then the one for P is what? Is 4 over 2, right? Y of O is O, and then y of P is negative 6, right? And then you divide by 2. Okay, so now that you have the following right, you can then say 4 divided by 2 is 2, and then you get negative 3. So that means those are the coordinates of M. They said calculate, so we did calculate. And another important thing, remember, I always say copy me as much as you can. You see, if you can copy me as much as you can even in your exam, you'll never go wrong, right? Because after getting that, I don't make a mistake. I put it on the diagram. Now determine the equation of the larger circle. The larger circle is this one. To get the equation, right, what do you need for an equation? Remember that there is 0 and 0. The center is at 0 and 0. This is a circle centered at origin. If a circle is centered at the origin, the general formula is x squared plus y squared is equal to r squared. In fact, let me write this. The general formula of a, let's say the center there is 0 and 0. And then the equation of a circle says that x minus a all squared, y minus b all squared is equals to r squared. Now, a and b are the coordinates of the center, changing the signs. So it's 0 here, and then it's 0 there. So we get x squared plus y squared being equal to r squared. But what is r? R is the radius squared. So we need to find the length of OP. But I don't stress myself finding the length of OP by calculating the length of OP. I just substitute the point P because the point P is lying on the circumference of the circle, isn't it? The circle is passing through that point. So I can say x is 4, and then y is what? Is negative 6 all squared. That will give me r squared. So if I put it in my calculator, 4 squared plus negative 6 all squared, I should get 52. 52. And there's no need of finding the root signs both sides, like rooting. It means the equation will be x squared plus y squared is equal to 52. Then you are done. You found the equation. Right. Ooh, what happened today? 4.2.2. Determine the equation of the small circle in this form. Wow, I like this form a lot, eh? X squared plus y squared plus cx plus dy plus e. It's a beautiful form. So the first thing is to rearrange that form nicely. So we can write it as x squared plus cx, and then plus y squared plus dy plus e is equal to 0. Yeah, imagine getting this in an exam. Quite interesting. So for a smaller circle, to get the equation, first of all, we don't really need to worry about this. You need to worry about the fact that you have a center, right? Since you have a center, you can use the general formula of a circle to get the equation of the circle. So it will be x minus a all squared plus y minus b all what? All squared, and then is equal to r squared. What is a? Since the center is, let me write it here. The center is 2 and negative 3. When on x here, on negative a, I put it as negative 2. Here it's positive, right? Here I write it as negative 2. And then, I'm not making a mistake, right? Here it's hey, I'm not making a mistake, right? Negative 3. Hey, so we should get x minus 2 all squared y plus 3 all squared is equal to r squared. What is very important is that here, if it's positive, you should have x minus 2. Here, since it's negative, you should have y plus 3. The signs must be different. Whichever way you solve it, guys, make sure that the signs are different. Yeah. So when you're using this formula, it's a matter of just substituting your x coordinate of the center, and then here substituting the y coordinate of the center. That is simply what I did. If you use the other one, which is this one, I don't know if you would use it, but if you happen to use something like this, x plus a all squared y plus b all squared, then you would have to, but we don't use this. This is not the one we use, because that one I think should give us an ellipse or something. So yeah, we say x minus a y minus b, then we simply substitute a and b as the coordinates of the center. I hope that is clear. 4.2.3, the equation, oh wait, we're not done though. Ooh, why am I rushing to? Now we need to get r. P is also the circle is passing through P. I can also substitute P. So x is 4, and then y is negative 6. Please here, I don't know, my soul is not well with this. I need you to remember, the matter of it being negative here, while here it's positive. You just check it on your last step here to say, here I have positive 2. Do I have minus 2 here? Then you say yes. Here I have negative 3. Do I have positive 3 here? Then you say yes. So it's just a matter of checking. Like that last step is when you are checking whether you are really correct. But the way of getting the answer is to substitute the value, the a as the x coordinate of the center, exactly as it is. B as the y coordinate of the center, exactly as it is. That's why I use brackets there. I hope that is clear. So you then put this in your calculator to get r squared. You get that as 13. So therefore, the equation of the circle is x minus 2 squared y plus 3 all squared is equal to 13. Then you can get it in that form, right? By just doing what? By expanding. When you expand this, it will simply be x squared minus 2x plus 4, and then this will be y squared. Minus 4x, right? Multiply by 2. It's expanding, guys, right? And then here plus 6y plus 9. Then you can say you have x squared. They want x squared plus y squared, x squared plus y squared. Then they want the one with x, meaning you say minus 4x. They want the one with y, you say plus 6y. 4 plus 9 is what? Is 13. Then you take the 13, this side becomes 0. So you have x squared plus y squared minus 4x plus 6y is equal to 0. That's how they wanted it. I hope that is clear. So it's just to expand. For the smaller circle, let me write that we found the equation as that before I proceed. We said x squared plus y squared is equals to 52 for the bigger circle. And then for the smaller circle, we said x minus 2 all squared y plus 3 all squared equals to 13. Tell me something. Do you still remember? Let me maybe do it on another page. I want us to see if we can still remember. let's just say you are given the equation of a circle in this form. Can you be able to find the center and the radius? Let's say you are given in this form. Can you be able to turn it into this form? X minus a all squared, y minus b all squared. Do you still remember how to do that? Now, I think someone once showed me this method that you can say, I'm hoping I'll remember it. Then you have y squared plus 6y. You firstly group them again, x, y, y. Then he said you take that x squared minus 4x, you find the derivative of it with respect to x. If you find the derivative here, we're already doing calculus. What is the derivative of x squared? That is 2x, right? And then the derivative of this is minus 4. Then what did he say? Oh, then he said you solve for x. You equate this to 0. You say 2x is equals to 4. Then you divide by 2. Divide by 2. He says x will be 2. So this will be the x coordinate of the center. It means the x coordinate of the center will be 2. Then you do a similar thing for this one. You say the derivative of, with respect to y, the derivative of y squared plus 6y. You say the answer will be 2y plus 6. Then you take that 2y plus 6, you equate it to 0, you solve for y, which will give you the y coordinate of the center. You divide by 2, divide by 2, it means y is equals to negative 3. It means this is your center here. Yeah, that's what he said. I remember. So indeed, it's true, ne? The center is 2 and negative 1. Beautiful method there. But then, how would you find the radius? How would you find the radius? The radius, I don't remember what he said, guys. I don't remember at all. Kind of what did he say? He said, oh, okay. He said, Joe, what did he say? He said if we write this like this, ne? And then we write this. And we already know that for the center we have 2 here, he then write minus 2. For the y is that, he writes that. Then he said equal to. Now he then say, now this is the part whereby you say, what that's the part whereby you say you take the negative 2, you divide it by 2, then you say squared, plus you take the 3 exactly the way it is and you square it. Then you'll have x minus 2 all squared plus y plus 3 all squared being equal to, I think this is 1 plus 3 over 2 is what? Is it 3 over 2? Yeah, 3 over 2 plus plus that, it's what? 9 over 4. I think this is not correct. 9 over 4. 13 over 4. For the radius, I don't remember what he said. You know what? Let's leave his method. But his method is very good for finding the center. You know, finding the center is very, very easy with his method. But otherwise, I just wanted to share that with you, right? But otherwise, you know that you have to complete the square. So when you complete the square, you will say you take x as it is. Then I say take this as it is again, but make sure that you divide by 2. Then you say all squared. Then you take this as it is. Then you take that as it is. Then you divide by 2. Then you say all squared. Then after that, this side, you're going to take the very same thing, then you square it, then you're gonna take the very same thing, then you square it. So now you're gonna have x minus 2 all squared plus y plus 3 all squared, which gives you 4 plus 9, which should be x minus 2 all squared plus y plus 3 all squared, which is 13. Yeah, my method, I will remember it because I've mastered it again. So that is what you do. Just take the middle term divided by 2, this you divide it by 2, then you take the very same things this side, but you just put a squared. If you had something else this side like 5, you would say 5 plus these things, right? Like this.
Sir?
Yeah.
We always divide by 2.
All the time, mama. All the time. So the center will be, I just changed the sign. From negative, I write it as positive. From positive, I write it as negative. Then I know that my radius squared will be 13. It means if I root both sides, the radius will be the square root of 13. Right. So that is simple. That is nice. I hope that we remember that method at least. The other one, I will remember maybe how he did the radius. Okay. So yeah, and that is exactly what we have here, right? We just wanted to test our skills, whether we still remember. The equation of RS. Oh, I'm running out of time. 3 minutes. Okay. Now, usually, again, now we know that for SR, the equation is y is equal to 2 over 3x. Good people, let's understand that the line RS is touching the circle at R. That means R is actually a special point. It is a what? It's a point, a point of intersection. Since it's a point of intersection, then we know what to do. We have to use Martinez equations to get the coordinates of R. So if we can use that real quick, we know the equation of, and here we know that x plus y squared, x squared y squared is 52 for the radius of the big equation of the bigger circle. Then we know that y is equals to 2 over 3 for RS. Right, so we're going to equate this y in there. Where we see y, this is what we're going to put in there. So we're going to say x plus 2 over 3 x squared. Then we can say x squared plus 4 over 9x squared is equals to 52. When you add there, you say 9 plus 4 is what? 9 plus 4 is 13. So you're going to have 13 over 9x squared is equals to 52. Then you can get x squared as 52 times 9 over 13. Root, then you can get the x at R. So it's the root of 52 times 9 over 13. You get 6. That means R, okay, so it will mean R is 6, and then yeah, the x of R is 6. Then to get y, you can substitute this 6 either in this equation or in this one. I'll probably use the easier one, so I'll say 2 over 3 into 6. Then 6 divided by 3 is 2, so I should get 4. So this is 4. So it means R is 6 and 4. R is 6 and 4. Now I need to get the coordinates of n, right? Since this was reflected about the y-axis, what will happen is that the x is going to change, but the y will not change. The x will now become negative 6, but the y will still be 4. Okay, then now to get the equation, right, let me just take this a bit up. Just to clarify, the reflection about the y-axis means the y is not changing, but x is gonna change the sign. Values are not changing, just that you're gonna change the sign. If I'm reflecting about the x-axis, it means if I reflected this about the x-axis, that will mean that I should have what? X will not change, it will be 6, but y will be -4. So let's understand that. Now let's go to 4. So this was what? 4.3. So we need to get we have r, we have n. So the distance of n is what? Of nr, man. So nr will simply be square root of y of r minus let's say x of r minus x of n all squared, y of r minus y of n all squared. Now x of r is 6, x of n is -6, and then y of r is 4, then you have -4 all squared. So that means the answer will be 12. So nr will be 12 units. Right, so that will be it for nr there. Then the last question, which is 4.4, the circle with center at M, this one, is reflected about the x-axis. Very, very good. Nice. What a beautiful question. It's reflected about the what? The x-axis. What does that mean? X will not change. It will remain as 2. But y is going to change the sign. So it will now be 2 and 3. Where is 2 and 3? That is on top there. On top here. So here we're going to have 2 and 3. Now it's a bit messy. I'm very sorry. But now the cycle now will be like this. Oh, I can draw a nice circle here, by the way. So it should be blue though, my favorite color. Center is that, so can make it a bit okay. It's not that perfect, guys, but it's trying to be perfect. Trust me, it's doing its best to be perfect. So this will be the other circle there, the blue one. So what are they saying? Oh, that is K now. So this will be K. Now they're saying calculate the length of the common chord of these two circles. The common chord, do you see the common chord? Is this guy here. This is the common chord. Here. So we want the length of this chord, which is beautiful. How would we get the length there? It just means since we already have the coordinate of O, we just need the coordinates of this guy, then we are done. We can get the distance. Yo, they wanted the length a lot in this question paper. This is around May, June 2018, by the way. May, June 2018. So it's the rewrite for 2018. Quite interesting questions there. But I think it was pretty easy. Now, let's see. I think here we are okay. Right. I can remove this side. Here we can. 4.4 now. The length. Okay. So the point there, it's a nice point. Isn't it an x-intercept? There. It is an x-intercept. So we just need to find the x-intercept, but of the one of which we have the equation, we have the equation of the smaller circle, isn't it? So we can use it to find the x-intercept. So we can simply say, since we know that we have x minus 2 all squared plus y plus 3 all squared, and then it's equals to 13, x-intercept will let y be what? 0. So we're gonna say 0 plus 3 all squared is equals to 13. Then you get x minus 2 all squared is equal to 13 minus 9. So it will be x minus 2 all squared is equals to 13 minus 9, I think it should give you 4. Then you root both sides. You root square root. This will be plus or minus, isn't it? So you are going to get that x minus 2 is going to be equal to plus or minus the root of 4. That means x minus 2 will be equal to plus or minus 2. So which means x minus 2 is equal to positive 2, or x minus 2 is equal to negative 2. That means x will be 4 or x will be 0. Which makes sense because this circle, the smaller circle here, has two x-intercepts. It is x-intercept at O and then at that point. This one is already at O. So it means this is the one we wanted. Right? So it means we have the coordinate of that other guy. We know it's 4 and 0. And now that we have that, we can simply find the answer. We can simply find the answer. So therefore the length will be what? The length that will be the length of what? Of the chord will be y x2 minus x1 all squared is the root, and then plus y2 minus y1 all squared. So x2 we can say is the 4 here, x1 would be the 0 there. The y at this point is 0 because it's an x-intercept, and then the y there is also 0. So the answer will simply be 4 units. Good questions. So that is it, guys, right? Try to practice as much as you can these things, right? They're very nice if you do a lot of questions on them just to get ahead. And another thing, do not, you see, analytical geometry, don't be afraid to construct. If you are afraid to construct, you might not see what is going on. Don't be afraid to draw, don't be afraid to construct. Okay? Then you should be okay. But I feel like this was a very, very nice question. Hi. Very nice question. For those who are doing physics, it's fine. So that will be it. But I have a question from IEB that I felt like was quite interesting. Let me show you real quick. Okay, here we go. This is the question here. I think this one was for 4 marks. 2 marks, in fact. They wanted the coordinates of D. How do you get the coordinates? Yes, ma'am. Let's read it first. A farmer uses a drone to check his fences for damage. So here's the drone. There it's drawn. Drone is drawn. Yeah, it's here, it's moving here, it's above. You must understand it's on top. A drone is on top, right? A, B, C, D are on the horizontal plane. So here's the ground. This part here is the ground. Down, down, down on the ground. D lies on the x-axis. At present, right now, the angle made between the line AD and the x-axis is 45 degrees. Then they want you to find the coordinates of D. How would you do it? But you got a very, very nice idea, ma'am. But I will advise you again. I'm going to say it again. When you're doing analytical, do not be afraid to construct. Actually, you can construct here, extend that line. And if you extend it, what will happen to this and that? Right, that will be what?
Vertical angles opposite, yeah.
Yes, vertically opposite angles. Nice, nice, nice. That's great, ma'am. So, in that way, we can get, like you said, right? We can get the gradient of AD as what? We can say tan 45 degrees is gonna give us the gradient of AD, which, yes, indeed, it's 1. The gradient is 1, but then the coordinate, how do we get that?
Then would you another way I think I could do is it, you know, the equation of AD, we can find the equation of AD, then since we found the gradient of AD, we can substitute it, then we can substitute the coordinates of D. We only have y, which is 0, then we would get x.
Oh, yeah, very, very nice.
Would it be long? Because,
like to say this, right? So we know the
the equation of yd, then since we have the gradients already, everything is there, then we just substitute the coordinates of D. We have x and 0, then we just find the x.
Okay. X is 1, then we get c as -2, right? So the equation is y is equals to x minus 2. That means since D is an x-intercept, at D we know that y will be 0. So say 0 is equals to x minus 2, so the x will be 2.
Would that work?
And then D is 2 and 0. But look, I don't know, try to look at it. If D is 2 and 0, and this guy here is 2 and 5, or maybe are they wrong? So here is 2 and 0, right? We get that this is 2 and 0, and then here 2 and 5. We look at where 2 is. These guys. But I would agree with you that unless if I make a mistake somewhere, is the calculations correct?
I think I might be wrong, so that's what I'm saying.
Let's see. If I think we should get the same thing. Let's use this one and get the coordinates, right? So if we were to calculate the gradient of AD, we would say y of D minus y of A, x of D minus x of A, right? So that means y at D we know it's 0, but y at A we know it's -2. X of D we don't have, but we know that here x of A is 1. So in that case, if you cross multiply, you're going to have x of D minus 1, and get it, this is 1 over 1. So x of D minus 1 is equals to 2, because 0 plus 2 is 2, 2 times 1 is 2.
Your equation was wrong, because it's supposed to be y is equal to x minus 3. Then let me see what happens if I substitute. Then I think x is supposed to be 3. X is supposed to be 3.
Oh, it should be -3.
Yes. So I used the equation. I like using this one because it's very nice and simple. Y minus y1 is equal to m brackets x minus x1. Then you just substitute them since we have the coordinates. Don't you have the memo of the paper?
The memo is us, ma'am. That is the memo. So x of D will be 3. Yeah, then that is the logical one. Yeah, I think the error that happened there, I see. I did not take 1 to the other side. Yeah. I felt that there was something there. So thank you so much for that. So that is definitely 3 and 0, and it's confirmed by this, right? That D should be 3 and 0, because if it was 2, it means it was supposed to be directly below, right? Directly below C. If it was 2, right? So that means, yeah, indeed it should be 3. It should be 3 here. Then that will be okay. That are the coordinates. That is the coordinates of D, 3 and 0. I think there was another question there, right? So the next question said calculate the size of ABC. ABC. So it will be this angle here. It's like angle B, right? This whole angle here. How do we get ABC. Okay, well, if we can check, right? If we can check, I would say, right, I would say we can maybe get like you can use many methods to get ABC. One method would be to use Vivian, right? Meaning you can find the length of AC, then you can find the length of BC, then you can find the length of AB, then you use cosine rule to get angle B. That is one method that you can do. So you would say AC squared is equal to BC squared plus AB squared minus 2BC times AB, and then you say cos of angle B, then you substitute. So it means you have to get the length of AC, BC, AB, then you'll be able to get it. But maybe another method you could use would be to say, wait, what is the gradient of BC? If you suspect that there might be a 90 degree though, you can say, what is the gradient of BC? That is going to be 5 minus 1 over 2 minus negative 2. That will be 4 over 4, which is 1. Then the gradient of AB would be what? 1 minus negative 2, meaning y of this minus that, then negative 2 minus 1. Then that should give us what? 1 plus 2 is 3. This is negative 3, so the answer is negative 1. Then you say, since the gradient of BC times the gradient of AB will be equal to 1 multiplied by negative 1, therefore, and giving you negative 1, therefore BC will be perpendicular to AB, which implies that angle B is 90 degrees, meaning ABC will be 90 degrees. So that is one way you can do it. But it works on suspicion to say maybe it's because you are suspecting a 90 degree. Right. And if we're getting a 90 degree there, if we're getting a 90 degree here, that means this is a diameter. AC should be a diameter, because it's only a diameter which subtends a 90 degree on the circumference. Right, so yeah, I just wanted to share those problems with you guys. I'm hoping that we have learned at least something, revised something, and yeah, we should continue with our revision streak. Remember that this week it's mostly paper 2, right? So that's why we're trying to revise paper 2 as much as we can. Next week we are all about paper 1. In fact, we start from the weekend, right? We are all about paper 1 until we write, so that on that weekend that is coming, you'll just be revising. In terms of Saturday and Sunday, you just be revising statistics. You quickly revise analytical, trigonometry, Euclid. You revise them. You're not panicking, because most of the things you would have done this week, you revise and then you write on that Monday that would be following. Best